A key technique used by researchers to study neurotransmission is electrophysiology. Electrophysiology provides detailed information on the timing and properties of the currents in a cell, but not the spatial information within the cell that microscopy techniques offer. So how can we see those calcium signals that trigger neurotransmitter release? In the early 1990s, fluorescent dyes were developed that glow brighter when they bind calcium, which allowed neuroscientists to study for the first time the calcium signals in synapses. In this movie, some neurons in a petri dish were incubated with a fluorescent calcium-binding dye, shown in green. The large bright blobs are the neuronal cell bodies, where the calcium concentration is often higher. The synapses are situated along the processes. When the neurons are stimulated, you can see fluctuations in the brightness of the dye as the calcium enters the synapses to trigger neurotransmitter release. I've labelled some of the synapses with white arrowheads to help you identify them. As you can see, there's a lot of information here with the connected neurons behaving like a network. Neuroscientists can use imaging software to place regions of interest over the synapses and measure the brightness of the dye during the experiment to study the timing and magnitude of the calcium responses. The graph on the right shows the quantification of the calcium signals in the synapse that's labelled with the green arrowhead. These experiments are really useful for studying the effects of drugs on calcium signalling, and for example, anti-epileptic drugs often target voltage-gated calcium channels.